Professor J.B. Joshi, Padma Bhushan, Chancellor ICT Mumbai, Emeritus Professor Homi Bhabha National Institute Mumbai, and our Honorable Chief Guest today, respected Dr. Renu Swarup, former DBT Secretary and Chairperson, Governing Council of IACS, respected Professor Kalabaran Maiti, Director IACS, respected Professor Shurid Ghosh, Dean Graduate Studies and Student Affairs and Chairman of the Convocation Committee IACS, respected Ms. Sharbani Shaha, Registrar IACS, respected dignitaries, faculty members, colleagues, students, ladies and gentlemen, a very good morning and welcome to the 5th Annual Convocation of the Indian Association for the Cultivation of Science. We begin today's program with a prayer, with sincere thankfulness to the Guru, who is the creator, sustainer, and destroyer, and who liberates us from the darkness of ignorance to the ocean of wisdom. Today we reminisce the glorious 150 years of heritage and achievements of the Indian Association for the Cultivation of Science, established by our founder, Dr. Mohendralal Sarkar. From the emergence of life to scattering of light to the unexplored cosmology, IACS has stood the test of times and unraveled many a scientific enigma. Sir C.V. Raman's wave in the sea, with reference to his discovery that the blue color of the sea is due to the scattering of sunlight by water molecules, a phenomenon he explained through his work on light scattering, demonstrating with experiments using a nickel prism that water molecules themselves scatter light, causing the blue hue. This finding, further explored with his collaborator Dr. K.S. Krishnan, led to the development of the Raman effect, which explains how light scatters with matter. The 150 years of IACS will immediately be followed by the centenary of the discovery of Raman effect of IACS. Having this at the backdrop, we will take you to the confluence of science and philosophy that blends perfectly with the spirit of today's vibrant and auspicious ceremony. The mighty waves of knowledge set the sky rolling, diffusing the past and future. Life goes on brilliantly shining with the wonderful wave of joy and prosperity. This very righteous thought was written in golden words by the great Kavi Guru Rabindranath Tagore, whose song Bipulo Tarango will be performed by our students Pranjal Sengupta, accompanied by Oshmit Jana on the tabla and Shupriya Shutradhar on the piano.
Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwara, Gurur Sakshat Param Brahma, Tasmai Shri Guruve Namaha. বিপুল তরঙ্গরে বিপুল তরঙ্গরে সব গগন উদ্বেলিয়া মগন করি অতীত অনাগত আলোকে উজ্জ্বল জীবনে চঞ্চল একই আনন্দ তরঙ্গ বিপুল তরঙ্গরে বিপুল তরঙ্গরে সব গগন উদ্বেলিয়া মগন করি অতীত অনাগত আলোকে উজ্জ্বল জীবনে চঞ্চল একই আনন্দ তরঙ্গ বিপুল তরঙ্গরে বিপুল তরঙ্গরে তাই দুলিছে দিন কর চন্দ্র তারা চমকি কম্পিছে চেতনা ধারা দুলিছে দিন কর চন্দ্র তারা চমকি কম্পিছে চেতনা ধারা আকুল চঞ্চল নাচে সংসার আকুল চঞ্চল নাচে সংসার কুহরে হৃদয় বিহঙ্গ বিপুল তরঙ্গরে বিপুল তরঙ্গরে সব গগন উদ্বেলিয়া মগন করি অতীত অনাগত আলোকে উজ্জ্বল জীবনে চঞ্চল একে আনন্দ তরঙ্গ বিপুল তরঙ্গরে বিপুল তরঙ্গরে। নমস্কার।
Thank you, students. We now welcome our guests. I request our colleagues, Ms. Shashwati Bhattacharya and Ms. Shohini Motilal, to welcome our guests. We welcome our honorable chief guest today, respected Professor J.B. Joshi. We welcome our Honorable Chairperson, Governing Council, respected Dr. Renu Swaroop. We welcome our Honorable Director, Professor Kaluvaran Maiti. We welcome our Dean, Graduate Studies and Student Affairs, and Chairman of the Convocation Committee, Professor Shurid Ghosh. We welcome our Registrar, Ms. Shorbani Shaha. Thank you, Ms. Bhattacharya and Ms. Motilal. May I now request Professor Shurid Ghosh to declare the convocation open.
Today, convocation of IACS deemed to be university has been called to distribute degrees to the candidates who have been certified worthy of degree by IACS. With the permission of the Chairperson Governing Council of IACS, I have great pleasure in declaring open this convocation.
May I now request Professor Kaluvaran Maiti, Director IACS, to give the welcome address and present the academic report.
Good morning. A hearty welcome to all of you, respected Chief Guest Professor Joshi, and our Council Chairman Dr. Renu Swaroop, and Professor Shurid Ghosh, our Registrar Mrs. Shorbani Shaha, all our honorable Council members and our faculty and colleagues, students. A hearty welcome to you all. It's a great honor and privilege for me to stand here and welcome you. As you know that we have already stepped into the 150th year of this institute, which is a momentous and a great achievement. No other institute has been able to do so. And so it's a pleasure and honor for me to really stand here and welcome you. the institute was founded on 29th July 1876 by Dr. Mohendralal Sarkar. As you know, that he is a great social reformer and a visionary, much ahead of his time. So he thought about the ethos or the practices which are so great that we have been able to continue for so long, and we are still in the formative stage. So we are growing with excellence and making differences. This is the institute where, you know, we have the pleasure to have C.V. Raman, who got Nobel Prize, which is the only Nobel Prize won in India in science. He, of course, discovered an effect which really changed the face of research completely, brought in a new era in scientific research, particularly identification of materials, material properties, and so on. Famous scientists like Professor S.N. Bose, who was a faculty here, who was a national professor. As you know, that he also discovered something which could have won Nobel Prize, and although he did not receive, but half of the particles are there in his name, so we call bosons. And many Nobel Prize came out based on the theory that he discovered. We also have pleasure of many great teachers, starting from Ashutosh Mukhopadhyay, Jagdish Chandra Bose, Acharya Prafulla Chandra Ray. Of course, he was a student here when he was a student in Presidency College. And you know, the chemical industry, somehow he is the father figure of, or founding person of the chemical industry in India. So any scientific luminary that you talk about, IACS has the pleasure of their association. And we are really extremely proud that we are continuing this tradition for so long. It's an autonomous institution under the Department of Science and Technology, Government of India, and with unique features of innovation and creativity. In 2018, IACS received the status of deemed to be university under the de novo category, which is the second DST autonomous body and which has this honor. But we have a unique feature, is that we also have undergraduate program, which no other DST institution has. So, so that way IACS has been really unique and continuing its tradition of teaching the Indians in a new and innovative way. In the year 2024-25, we published about 429 high-quality research papers with a extremely high average impact factor of 5.8, several book chapters, about 167 students, they are graduating today. So I really congratulate all of you for your hard work, not only you, your family, and the faculty members who have been working hard to your success. The high quality research has been recognized internationally because you know that IACS always have been ranked at the top of all the DST institutions for many years, and which continues to be so now. And we are the top ranked autonomous body under DST even now. And the high quality research has been recognized by many awards. And so I think we have about 65 or 66 faculty at present. Almost half of them, they are editors in a very prestigious international journals, which is a great achievement. I mean, editorialship, you know, that it doesn't come for free. So you need a extremely high reputation and good work to get such recognition. Apart from that, of course, many of our colleagues, I'm not reading their names, so they have got national recognitions like Fellow of Indian Academy of Sciences, Fellow of National Academy of Sciences, India, and Indian National Science Academy. So all the three major academy. Many of our students, I have seen that about 25 research scholars received Best Poster Prize in various international meetings during the last year. So which shows the quality of the teaching that gets percolated to our graduate students. We have organized many colloquiums. Several distinguished scientists, they visited IACS. For example, Professor Dixnoy from University of Rennes, France, he talked about catalytic functionalization of phosphine-CH bonds and new reactions of interrupted reduction intermediates. Professor Varganov from University of Nevada, USA, so he talked about non-adiabatic molecular dynamics with the crystal field Hamiltonian to study spin dynamics in lanthanide complexes. Professor Indrajit Bhattacharya from TCS, he talked about knowledge-based questions answering in the age of LLMs. Professor Partho Bhaumik from IIT Kharagpur, he talked about curvature estimation made simple from real to digital. Professor Prasenjit Mitra talked about large language models, which is, the thrust area of research at present, and people have been talking about AIs, ML, machine learning, and so on. Professor Amitabh Das from University of South Carolina talked about civilizing AI, examining emerging capabilities of mitigating potential risk of foundation models. Professor Sandeep Trivedi from TIFR, he talked about universal theme of physics from black to a grain of graphene. Professor Anant Narayan from ISC Bangalore talked about joy of discovery in modern era, some reflections and directions. IACS took many initiatives in science outreach, encouraging future program. As you know, this is one of the major vision of our founder, that we do innovative research and it should be also brought to the society. So IACS plays that role extremely efficiently over the years. So our third and fourth year science students of the 5-year integrated MSc program, so they visited several institutions like ISERC, Vishwabharati, Shantiniketan, and so on. And they have actually discussed their research activity to the students. So it has got huge appreciation. Professor Arindam Banerjee, Professor Rupa Mukherjee, Professor T.K. Pine delivered lectures in addition to their visits to various laboratories. Professor Somabrata Acharya, he has undertaken a seed program which basically is related to bringing science to the ST community, which are highly underprivileged. So we have a mobile lab which goes there and they are demonstrated to the ST students. We actively participate in inter-institute collaborations, which was another aspect that Dr. Mahendralal Sarkar emphasized. The major theme was not to create a research institution in isolation, but essentially to complement with the innovative research activity to the existing academic institutions. Very much like the city cluster that we talk about, hub and spoke model that we talk about at this. So the whole entire concept was actually built in our founder's vision. So as you know that we actively participated in inter-institute collaborations involving academia, industry, and government agencies. Solar energy research is being conducted along with the vision of Ministry of New and Renewable Energy, MNRE. A continuous ambient air quality monitoring system, ACAAQMS, is in operation in collaboration with the West Bengal Pollution Control Board at IACS. IACS remains the nodal institute of India in Asia Pacific Center for Theoretical Physics, APCTP, based in Seoul, South Korea. There is a co-publishing agreement between Springer Limited and IACS to run Indian Journal of Physics. Tripartite water research agreement has been in operation between IACS, University of Roma Tri, and University of Cagliari, Italy. There are India-Japan collaborative research projects in molecular science with the Institute for Molecular Science, Japan, National Institute of Natural Sciences, NINS, Japan, Sirius, and TUAS IACS postdoctoral fellowship program, which are currently underway. We also have a lot of industry partnership. For example, we initiated collaboration with GK Machineries and Robotics Private Limited for the development of drone-assisted pheromone dispersal through nanosensors for the early detection of pest infestation in cotton farming land. A startup grant was sanctioned from Biotechnology Industry Research Assistance Council, BIRAC, DBT, for the development of point-of-care device for the selective detection of human serum albumin, creatinine kinase, and kidney injury molecule 1 for the accurate determination of acute kidney injury. BIRAC DBT has funded the formation of a startup company, GR Agritech Labs, through Biotechnology Ignition Grant, where the scientists from IACS are part of the team members in this project. So like that, there are several such initiatives we have taken. We have a collaboration with IIT Kharagpur for our ongoing biology teaching programs. IACS has been proactive in organizing various national events mandated by Government of India. Students and staffs organize various social and cultural events to keep IACS a vibrant place. Being an academic institution of high repute and a national center for innovation and creativity as envisaged by the founder, Dr. Mahendralal Sarkar, it will be our mission to continue to do high-quality research in basic sciences as well as potential translational research and impart good quality education in varied areas of science at the undergraduate and postgraduate level. I once again congratulate all our students graduating and their family members for their continued support. Without really great support from every aspects of life, including the family, it's not really easy to complete such a great feat. So I also congratulate all our colleagues here who has done an outstanding work leaving their family behind, which made this institute of great reputation and the future generation to remember. So as you know that so the students, those who are graduating today, you know that with this achievement, there are a lot of responsibility comes with you. So, you know, the academic community in any society, they are supposed to be the leader which directs a society. So anything that you do, you cannot really say that, okay, I did this mistake because of these restrictions and so on. So there will be everything, many ups and downs in life. But of course, you are the one who is leading, who has to take the responsibility and take it forward. Okay? So you are the ambassador of the country. So you really cannot stop behind because of some hurdles that you face in your life. The honesty and integrity has to be the maximum at your level. So because you are basically the intellectual community of the society. So since you really carry the flag forward and the leader of future generation, as you know, the Swami Vivekananda, what he said, that wherever you go, you must ensure to make a mark. Okay, so you need to really bring in a difference. So that's the way you lead us to the future. So I request all the students who are graduating to please stand up and take an oath today that you will fulfill the responsibility of this community. So I'll read something. So you all have to say, I do promise. So I should be able to hear it, okay? So do you solemnly and sincerely promise and declare that if admitted to the degree for which you have been qualified, you will in your daily life and conversation conduct yourself and become worthy members of the university. I need to hear it much louder. Do you solemnly and sincerely promise and declare that to the utmost of your opportunity and ability, you will use your powers for the promotion of true learning and in the service of your fellow men? Thank you. Do you solemnly and sincerely promise that you will faithfully and diligently fulfill the duties of the profession to which you will eventually belong, and that you will on all occasions maintain its purity and reputation? Thank you. By virtue of the authority vested in me as the Director of IACS, it's my pleasure to admit you to the degrees for which you have been declared qualified by the IACS deemed to be university. Thank you very much.
May I now request Dr. Renu Swarup, Chairperson Governing Council, to give her address.
A very good morning and namaskar to all of you. Respected Professor Joshi, the chief guest for today, Dr. Maiti, Dr. Ghosh, Sarbani Saha, the members of the Governing Council, the deans of the institute, the chairs of the schools, the faculty, my young students, and your parents. It is indeed a matter of great pleasure for me to stand here and convey my greetings to all of you on the occasion of this 5th convocation of this very prestigious institute. I do have great pleasure in presiding over this convocation as the chair of the council. I think being part of the family of IACS itself is a great privilege for each of us who's here today. As was said by the director, and each of you who's graduating out, all the faculty are aware that IACS, the Indian Association for Cultivation of Science, is one of its kind. It's an institute which has a very rich heritage, and as has already been said, it's into its 150th year now, set up by the stalwarts of science. And this was set up, as has been said, to cultivate, encourage creativity and innovation in natural sciences. This institute, and I'm sure each of you who's here is proud to be a part of it, because this stands tall and unparalleled in our history of, as I said, leading Indian scientists who have laid the foundation of science and technology, not just being associated with this institute, but they've laid the foundation for the journey of science and technology in our country. We all know, and Dr. Maiti in his address has indicated, and definitely each of you who's part of the institute knows, that we are all proud of the fact that Sir C.V. Raman started his experimental research on Raman effect, which got him the Nobel Prize. And you heard when our dear colleague spoke about how you're into the 150th year, and straight after this you'll start the 100th year of the C.V. Raman. I mean, these are not just numbers or milestones. These are very important to help us to understand what the journey of science in our country is. For the young students here, when you hear the name of C.V. Raman, you hear the name of Professor S.N. Bose, Professor J.C. Bose, Professor Krishna, and Dr. Amal Chakravarti. These would seem like names to you. But remember, They were all scientists of this country. We are still waiting for the next Nobel Prize in our country. It's not going to come or drop from the roof from somewhere. It's one of you that's going to move forward and get this prize. It's very easy to sit back and say, oh my God, how can I do this? But believe me, it's that conviction inside you to say one of you is probably going to be the next Nobel Prize winner for us. And we are still, as I said, in our country waiting for it. The fact that you're part of this rich legacy of this institute, and your director said it very correctly, gives you an added responsibility. The added responsibility is that you have to not just carry, as he said, the torch forward, but you have to retain the stature and the culture which this institute has provided you. You've all imbibed, I'm sure, in these many years that you've been associated with this institute, the core values with which this institute was founded. And it's up to you now, because now you move out of the portals of this institute. You move into the larger world. So you become really the one who's going to take this message forward. This, of course, we are all very pleased that IACS is a deemed university for a few years now, and it has been providing this high-quality education in emerging areas of science, technology, different areas of translational research, innovation, basic research, discovery research. But I think the uniqueness of this institute is the thrust that it lays on these interdisciplinary, integrated, cross-cutting science areas. With the different schools that you have, with the state-of-art infrastructure that you have, the Technical Research Center, you've shown excellent performance. And I think the report which was read out by the director, which gave us the number of publications, the number of patents, this definitely sort of fills all of us with immense pride. But now it's your responsibility as the young students graduating out, and not just the students, it's of course the faculties as well, to make sure that this increasing level of excellence is seen as we move in the journey of this institute, as we get into the 150th year, move towards the second century of this institute, to see that there's an increasing level of excellence both in research, education, and translation. I'm very pleased in this fifth convocation to see that over these years there's been an increasing number of students graduating, rightly said, undergraduate. I mean, for a DST institute, deemed university, to have an undergraduate, to have postgraduate and PhD degrees. I would definitely like to congratulate all the faculty and scientists of this institute who've played such an important role in providing this level of education to the students that they are today now emerging as our future scientists as we move on. Young students, today is a very important day in your life. You, as I said, are graduating out of this institute. And remember one thing, you may not realize it today, but a couple of years later, maybe a decade or so later, when you look back as an alumni of this institute, you will see that what basic foundations this institute has laid for you are going to play an important role as you move into your long career ahead. All of us, when we moved out of college, were, the first thought that comes to you is, and I'm sure all of you are going to do that, when you get out with your degrees, you're just going to fling your caps up and say, I've got my degree today. Enjoy this moment. It's not going to come back to you again. Because now you're going to be burdened with more and more responsibility. All of us have faced that, come out of this, moved into a career. But I think what is important is your inquisitiveness, which your mind must have as a young scientist. Don't let that inquisitive nature die out at any point of time. Let me tell you, learning never stops. Even today, my most enjoyable moment is when I hear a colloquium or hear a faculty bring out a new area of research, which is a new learning for me. Even today, I'm learning. Learning never stops. The day you stop learning, you've stagnated. So remember, your inquisitive nature must move on, and it's that inquisitive nature which will trigger ideas for new discovery, new translation. Science is moving at such a fast pace, and we cannot let it slow down. And how is that going to happen? That vision that we have of moving ahead is only going to be with the passion that you young students bring out as we move forward. I think it's more important that whatever ideas you have, you start looking at ways in which you give wings to those ideas, and you must give wings, because it's those wings that you give to your ideas that will help you to fly and move into out-of-box thinking areas which we need so much today. That's really what brings in the innovativeness and the newness of the science that we do. Every university has a huge responsibility to, we've heard about this institute's collaboration with industry and startups. We are seeing more of that culture moving on. And initially, we felt that that whole space was probably in universities and institutes like the IITs and others, but I'm so pleased to see that that's moving into universities like this. And we must have that entrepreneurial culture, that startup culture, because that helps you to move into it. So I think what is important is you have a plethora of opportunities before you when you graduate out of this. Academic research, entrepreneurial journeys, various other fields that you may want to take in. And I think you must try to see that you pick up what is it that it becomes your passion to move ahead. But I would like to mention here that the mentorship that your faculty has provided you is very important. And that mentorship is what you must see as you take forward. Keep that with you, because that's a learning that we would want to see that we take it ahead as we move on. Today, in the various areas of science that we are progressing, as I said, from discovery research to technology development to our whole area of startup ecosystem, we've seen newer areas coming up in science and developing. This institute, as has been rightly said, has a huge responsibility to see how you deliver to society. So what are those challenges for which you have to find innovative solutions? We have exhibited our strength in emerging technologies, but we must look at newer areas as we move forward to make technology affordable, accessible, and reaching the last mile. Even areas like quantum science, nanotechnology, nanomaterials, regenerative medicine, cell and gene therapy, genomics, artificial intelligence, we can go on and on and on. Today, India has the best of the academic research infrastructure and the capacities and the caliber to deliver. And you are the ones that we are hoping young students will be able to take this forward. Today we stand at an inflection point. There is no room for incremental growth. It has to be an exponential leap that we take on. And that exponential leap will come with this high-risk innovation that you do. Just taking on a Me Too research doesn't help. You must look at innovative ideas, high-risk innovation ideas that you can take forward, cutting-edge, disruptive technologies. They're high risk, but then you have the whole ecosystem to support you. And I think what is important is we must remember that science, technology, and innovation, these are the three important pillars which target our people, our society, and our communities. If you keep that at the back of your mind, your science will always move in that direction to see that it delivers as we move on. I'll conclude by a message to you, and that is, remember one thing. Science has no boundaries at all. It does not recognize any boundaries. It has to be our ambition, our belief, and our commitment that whatever we do has to be something that impacts our society, makes our planet, our universe healthy. Of course, we have a lot of sustainable goals, etc., but the bottom line is, how do you impact society? Young students, once again, my heartiest congratulations to you. To all the parents who are here, it's a proud day for you today. Your children are graduating, getting into a new journey. But again, my message, last message to you is stay focused. Stay focused, stay determined, move with passion. And I'll conclude with a quote from Swami Vivekananda, which will take this message to you a little stronger. Swami Vivekananda said, and I quote, "Take up one idea, make that one idea your life, think of it, dream of it, live on that idea. Let the brain, muscle, nerves, every part of your body be full of that idea and just leave every other idea alone." Unquote. So you see, that's the focus, that's the determination that you have to take forward as students. So once again, heartiest congratulations, enjoy today, and be sure that you have a wonderful future ahead, and all my good wishes and success to you for your future success as you move on. Thank you so much.
Thank you, Madam, for your valuable words. We would now request our chief guest, Professor J.B. Joshi, to give his address. We request our director, Professor Kalabaran Maiti, to give an introduction.
Good morning again. So it's really my privilege to introduce Professor Joshi. I know him for, at least his name, for many, many years, and his great achievements. Somehow I have not been able to meet him personally. So I really thank Professor Joshi to kindly accept our invitation and be here despite his extremely busy schedule. You know, I mean, he has really served the country for many, many years. Okay, but still he is really moving around all over the country, going to the grassroots level, going to the villages, and trying to educate people in various fields which will benefit the society. Professor Joshi, he is popularly known as J.B. Joshi, is one of the well-known names in the fields of chemical and nuclear engineering for his innovations in nuclear reactor design. Professor Joshi is widely regarded as a highly respected teacher. He was born on May 28, 1949 at Mysore, Satara, Maharashtra. He received his BE in 1971 and ME in 1972 in chemical engineering from the University Department of Chemical Technology, which is called UDCT. Presently, the Institute of Chemical Technology, I mean, the name got changed, so under the University of Mumbai. He completed his PhD in 1977 under the supervision of Professor Manmohan Sharma. You know, a great name in that the society. Professor Joshi worked at the UDCT in different positions, retired at the age of 60 as its director in 2009. Now he is the chancellor of the same institution. So during his tenure at UDCT, he took several innovative steps for the advancement of the field of chemical engineering and its societal applications. For instance, he organized around 200 science workshops within the period of 1999 and 2000. He was one of the key persons for getting the research funds by way of research contracts, donations, and project consultancies. Professor Joshi is credited with many innovative designs in the area of multi-phase nuclear reactors, such as multi-phase purged and mechanically agitated reactors, which has helped setting up a large number of commercial-sized reactors in India and abroad. Professor Joshi is widely regarded as a great mentor teacher, guided about 100 doctoral students, 60 master students, and a large number of postdoctoral fellows. He published close to 1,000 scientific papers in reputed peer-reviewed journals with over 31,000 citations and H-index 86. Chemical Technology Journal US has recommended his procedure 5 times. Some of his notable scientific works are development of in-house codes for computational fluid dynamics, for multiphase dispersions and complex geometries, performed the first laser Doppler anemometer LDA measurements in multiphase dispersions, development of an algorithm for the prediction of fractional gas holdup and bubble size distribution, deployment of the P4 technique to shadowgraphy for measuring motion of dispersed phases, bubbles, drops, and particles, development of a methodology for estimating detailed knowledge of the entire range of length, velocity, and energy scales. I mean, there are several I have listed. I'm not making you wait for long. So, a great achiever and innovator of the time. He has served on editorial advisory board of several well-known and peer-reviewed international journals like Canadian Journal of Chemical Engineering, Chemical Engineering Research Design, Chemical Engineering Science, and so on, reviews of chemical engineering. He received several awards and recognitions all through his career. For example, Amar Dai Chem Award 1983 for excellence in research and development by the Indian Institute of Chemical Engineers, Hardilia Award, Bashvik Award, Dr. KJ Nai Gold Medal, Chemtech Foundation Award, Goel Foundation Award, Dr. Anji Reddy Innovation Award, Indian Institute of Chemical Engineering Engineers Award, and so on. He received the most prestigious academic recognition in India, as you know, Shanti Swarup Bhatnagar Prize for Engineering Sciences in 1991. He is the fellow of all Indian academies, the World Academy of Sciences, and J.C. Bose Fellow. In addition to his outstanding academic contribution, he also contributed significantly in the upliftment of the society at large. In 2014, he received the third highest civilian award in India, Padma Bhushan, from the former Indian President Pranab Mukherjee for his services to the field of nuclear science and chemical engineering. After his retirement, he joined Homi Bhabha National Institute, Department of Atomic Energy, Mumbai, as a Homi Bhabha Chair Professor, where he is an emeritus professor now and also serving as a Chancellor of the Institute of Chemical Technology. So he has worked tirelessly for the upliftment of economically poor and underprivileged section of the society in various rural areas in India. He puts a lot of effort to utilize scientific approaches in rural areas, development of rural economy through science, energy conservation and sustainable development, etc. It's really a great honor for us that he is gracing the dais today here at IACS, and I'm sure all our graduating students is really fortunate to have him here. I welcome Professor Joshi for his talk here today. Thank you very much.
Thank you, Professor Kalabaran. Respected Chairperson, Dr. Renu Swarup, Director Professor Kalabaran, other distinguished personalities on the dais, off the dais, university functionaries, non-teaching staff, and my dear student friends.
So this is the pointer.
I feel indeed honored to be in the four walls of this prestigious institution, IACS. And you are graduating from this institution. Kindly accept my heartiest congratulations on your getting a degree. I also congratulate and give huge compliments to the faculty for the kind of research they are performing and publishing throughout the world. I have gone through vision statements of variety of universities and institutions in India, in Europe, in USA. And typically, Yeah. I was saying I had gone through several vision statements, and these words are common: science beyond boundary, invention, discovery, innovation, and society. Alternatively, these words are put here and there, and finally the vision statement is made. But there are two very important components to vision statement, either this or any other. We shall generate new frontier knowledge. That is first part of the vision statement. We shall generate new frontier knowledge. And second part is use it, implement it for the welfare of society. So these two parts of the statement, of vision statement, are already there. So well-being of the society, and if you take our society as India, the most important problem of our nation is poverty. So the objective, the vision becomes how we can address that problem and increase the per capita income. It is very well known that the per capita income of that nation is strongly related to innovative ability of that society. Now please see the next graph. Is anybody helping me? Right. So there are about 50-60 nations. So our innovation index is the lowest. Our per capita income is also lowest. China is about 3 times. Switzerland is several times. So this particular graph, let us keep it in our mind for next 25 minutes. That is my lecture time. Next slide. Yeah. See, normally the income of any nation comes from 3 sources: industrial activity and possible export of items, the agriculture, and the service industry. If we take variety of sectors, I mean chemical sector, but take mechanical, electronic, we are not doing even 1% of business throughout the world, 1%. So our income from the business, take Ayurveda, the science we established in India, and see the business based on Ayurveda, we do just 1% again. Go to agriculture, our productivity, take any crop, rice, wheat, at least 3 times less. Potato, tomato, 50 times less. And takes the service industry, the young people would like to join IT industry, starting salary is 50,000, goes to 1 lakh. But there is no big value addition. There are no softwares generated from India. Some small exceptions are there, but like Word and Excel, the simplest one, the Microsoft earns millions and billions of dollars. We are not doing that. So 3 major sources of the nation: the industrial activity, the agriculture, and the service industry, where the income from these 3 sources is very low, divided by population, that number comes 140th from the top in the list of industries. There is no innovation, and we are at the bottom. Please remember this, and I am going to refer to this sentence again and again. We shall develop new knowledge at the frontier and implement it for the welfare of society. Society is India, and welfare is removing the poverty or increase the per capita income. Even though we are poor, how many things we buy? A poor nation. Crude oil, we buy 20 lakh crores worth crude oil. And I have made a big list. And I have taken it from internet. You can also look at that list. And you can make 10 slides out of the number of just take one item about import-export. On the east coast of India, that is starting from Bengal, Orissa, and Andhra Pradesh, the sand contains titanium. How much sand we have? 600 million tons. We are the second largest having sand after South Africa. And how much sand we have? If we have technology for titanium, then it is sufficient for next 500 years. But what do? We sell the sand at 6 rupees a kilogram and import titanium at 2,500. My dear students, try to find out these examples, as Renu Madam said. Take any one of this as a passion and take it up to the end, up to the business. Next slide. This is one problem our nation is facing, where there is a possibility of increasing per capita income. The agricultural residue at present is 600 million tons. And what is done with that? It is burnt. Most of it is burnt. And it creates pollution of carbon monoxide, methane, number of particles per meter cube, huge pollution. Delhi, it is famous for pollution in November, December, but the entire country is facing that problem. Next slide. This process is known. That is, if any agricultural waste or any cellulose, hemicellulose, lignin is heated up to 350, 400 degrees, you get gas liquid solid products. So we got a sponsorship from a private company, United Phosphorus Limited, about 60 lakh rupees. And students studied the kinetics of pyrolysis of about 30 crops. And they saw in the literature another 800 crops have been investigated in the literature. So those 800 plus our 20, 30, the students used AI. Now, if you give any agricultural waste, from proximate and ultimate analysis, you can predict the kinetics. You need not do any experiment. With this background, we went to DST. That is, we want to scale this up for the society. DST gave 10 crores of rupees with the condition that industry must participate 25%. That money we got from the same company and scaled it up to 1 ton per day. MNRE, they wanted the same thing further for biohydrogen. And they gave about 33 crores of rupees with the same condition that 20% shall come from industry. We have already installed 5 tons per day plant where we will not get these products, gas liquid solid. We may get some quantity but it will be gasified and will get carbon monoxide and hydrogen. Carbon monoxide, it will be further reacted with water to get additional hydrogen. And whatever residue remains in the form of gas liquid solid, that will be also reformed. So in Pune, we have installed this plant and we will scale it up. In the meantime, Government of Maharashtra gave us 15 crores of rupees, us means my institute, 15 crores of rupees for handling the problem of only one crop, that is bamboo. In one of our districts, it's a huge, and people are poor, but huge quantity of bamboo. So we have gas liquid solid products. Next slide. So we completed this, invited industry and told them the business model. That is, if you make a cluster of 5 villages, then total available agricultural biomass will be about, from 1,000 hectares, 5,000 tons. Made that entire. Give 3 rupees to the farmer. Please note, please be attentive now. The best cash crop in India is sugarcane. And it is purchased at 3 rupees a kilogram. In this business model, it will be 4 rupees for any biomass. If you are growing rice, wheat, the main crop you take already. But whatever is wastage, you sell at 4 rupees a kilogram. We make all these products. The liquid product, in the earlier slide I showed you, we buy crude petroleum for the refinery, which is 20 lakh crores. So this crude oil we get, we collaborated with Bharat Petroleum Corporation and requested them to try this crude in their catalytic cracker. So they could mix up to 5%. Above 5%, the real crude has a good H/C ratio, and here in our the liquid product, the carbon is more, and therefore catalyst gets deactivated. So the problem was to adjust H/C ratio. And we collected a lot of plastic waste, which has a good H/C ratio, mixed it with agricultural, and again we could mix up to 15%, but up to 15%. Then we decided to hydrogenate a little bit, do hydrotreating of the liquid product of pyrolysis, and we could adjust the H/C ratio where there is no problem of catalyst deactivation. On the other hand, get 20% more gasoline. It is so profitable, so beneficial. Perform research at the frontier end, implement it for the benefit of society. What is benefit of society? The number of new jobs, 1.6 crores. Energy produced is 2,000 million tons of bio oil, which is practically sufficient for our nation. Energy produced per cluster is 50,000, and extra per capita income is 45,000 rupees, which is approximately per capita income of villagers, 45,000. So we make another 45,000 with the help of this. The technology is well established. One point I'll tell you, I have at least 50 examples. If this technology is purchased from outside, we are able to establish in 1/10 of the cost. 1/10 of the cost. And there are many such examples which we can address for reducing the number of slides. All those opportunities are cut. I have 4 slides on the opportunities. You got actually the per capita income, the number of rupees per person we are 140th from the top. But as far as number of problems per person are concerned, which need to address for solution, we are highest in the world, number of problems. And we are busy in creating also problems, and problems are already there. What I want to re-emphasize is we're able to produce 50,000, 45,000 per capita, extra per capita income. Next slide. This is another technology we developed, and Reliance is ready to implement it. It is conversion of entire agricultural residue anaerobically to methane. Next slide. Here I wanted to show that the results of this research we could publish in Nature journal. So be at the frontier of knowledge and use it for the welfare of the society. Next slide. Is anybody able to see cashew nut fruit? Anyway, in one of the districts of Maharashtra, that is Sindhudurga, it is the highest producer of cashew nuts. And what farmers do? They plug the cashew nut and throw the fruit. How many fruits they throw? 10 lakh tons. One district, 10 lakh tons. What I'm trying to tell you is how many problems. I'm giving you a taste of different problems. For making 1 liter of ethanol using these fruits, we need 20 rupees. And farmers definitely want 3 rupees for their fruits. So 20 kilos per liter. So for 1 liter of ethanol, you need to spend 60 rupees. And about 3-4 years ago, the central government's controlled rate was 48 rupees. So it was never commercialized, never. No possibility at all. Therefore, what my students did, they analyzed the fruit. It had vitamin A, vitamin B, vitamin C, anacardic acid, dietary fibers, polyphenols, tannin. And what students did, with the help of chemical engineering operations of leaching, extraction, chromatographic separation, and so on, they separated all these products and purified it up to 9999. There was a corona in between. They used that time for finding out where is the market. It was available in the internet. So which nation produces maximum maybe anacardic acid, at what price they are. So this survey and whatever is reported in the literature, we always feel that those prices are inflated prices. We took 50% of that. Why this business was not happening? And every year 1 lakh tons were thrown, and it was creating methane and warming the atmosphere. After separating this, instead of getting 48 rupees, there was a possibility to get 248 rupees. So this process is completely developed in the laboratory. The equipment have been purchased for 1 ton per day, and our specialty of our institution is you prove it at any scale, we shall scale it up at any scale. 1 kilo, 1 ton, 500 tons, 1 lakh tons, that is the specialty of our institute. So we will put, Maharashtra government is giving money. The investment for 25,000 tons per year is about 60 crores. The government is giving money. The only small rider is, out of 60 crores, 6 crores you collect from the farmers. We will give 54 crores. The local bank, Sindhudurga District Cooperative Bank, they also joined us, and they promised the farmers, if it is this attractive, we will give loan for 10,000 rupees for 6,000 farmers. 6 crores also get collected. Once there is a wealth in any societal problem, so this was a cashew nut. Next slide. So again, I'm showing the end slide. New jobs for 25,000 tons per day, 400. We can put 40 plants. So 16,000 jobs per district. And value to the farmers, 3 rupees a kg, even if you take that low, increase in per capita income by this business is another 40,000 rupees. Our vision statement is develop knowledge at the frontier of the society and implement this knowledge for the welfare. And the welfare that I defined for my lecture is to increase the per capita income. The first business, 45,000, second business, and every district in Maharashtra, and if it is in Maharashtra, every district of the nation, there will be some opportunity. There is a person, Renu madam will be knowing, Professor Anil Gupta. He has listed 100,000 opportunities, 100,000 opportunities. So let us start research and make our nation rich. Next slide. Same thing, jackfruit. Jackfruit is more profitable than cashew nuts. So we have started work on this. Next slide. Titanium, this slide I showed you. So I thought that with the help of one industrialist, very innovative industrialist, Dr. Ghada, he is no more, but he supported and his people are still supporting. Next slide. The aluminum industry, first of all, the natural bauxite is reacted with caustic soda. We get sodium aluminate, and whatever is not soluble is thrown out, filtered. And that color is red, and it is called red mud. In West Bengal, Orissa, including all these places, there are huge hills of red mud. What is there in the red mud? Titanium, 8, 9, 10%, aluminum, 30, 35, 40%, and iron, again 30, 35%. Remaining must be siliceous matter. So this red mud, we subjected to smelting, and we get different oxides, TiO2, L2O3 after smelting. And it was carbochlorinated, and we got respective chlorides, TiCl4, AlCl3, and FeCl3. And since the boiling points are very, very different for these chlorides, we purified them by distillation and took TiCl4 and electrolyzed it to get titanium and 2Cl. The import price is 2,500. Our cost of production is 500 rupees. 500 rupees. So these two states, we have scaled it up to 2 kilogram scale. We will scale it up to 40 kilogram scale and then build a new plant. Next slide. Synthesis of carbon nanotubes, graphene and graphene oxide. I wanted carbon nanotubes for doing some experiments in making catalyst using, instead of activated carbon, make carbon nanotube and make it as a support. I got a quotation from United States, $10 per 1 gram of carbon nanotubes, $10. China is much cheaper. $10 per, 5 times cheaper, $10 per gram. So I pose this challenge to my students, and all the successes I'm telling you today are of students, of my students, 98% contribution. So they made carbon nanotube, exactly the same quality of United States. And what is the price? $50 a gram, $10 a gram, our cost of production is 3 cents a gram. 3 cents a gram. We are able to make 1 kilogram in $30. Transferred the technology, we have started commercializing. We can make large number of, from carbon nanotubes, using polymers, very high molecular density polyethylene, we can make a composite. So our students, they made a composite, and from that composite, on the nanoparticles, there were 3 girls and 2 boys. Those girls, they were taught by their mothers how to stitch. So they took the composite and stitched a bulletproof jacket. Next slide. So this is a bulletproof jacket. So with the help of the police laboratory, the military laboratory, at 5 places, our higher authorities in atomic energy, one high authority is present here today, Professor Kamachi Mudli, with their help. Otherwise, it was not possible as an Institute of Chemical Technology. Laboratory was of BRC, scientists were, students were, I was just the guide. And the central government proved, all the laboratories proved that all kinds of bullets, this bulletproof jacket can take up. Knowing this success, our Honorable Prime Minister announced in the Parliament, now onwards we shall not import bulletproof jacket, which costs 1.5 lakh rupees. Our technology costs 15,000 rupees. This is, I think, second or third example I am giving. Wherever if we produce science and technology ourselves and scale it up, the 15,000 rupees. The graphene we made. Graphene, again composite with polymer. You know wind energy. The wind energy, that fan length is about 80 meters. Why 80 meters? Because whatever is the compressive strength and tensile strength available with the fan, we can make only 80 meters. Our graphene composite is permitting up to 200 meters. So at the same location, if it is a 1 megawatt power plant, wind power plant, it will give at least 4 megawatt at the same time. Per capita will increase. Generate new knowledge, implement in the society, and generate the per capita income. Next. So CNT, carbon nanotubes, are very good as hydrogen storage. Catalyst support, I mentioned to you. The student who did this work, he's starting his factory startup unit. 16,000 crore worth catalyst we are buying. And he showed that if noble metals, palladium, platinum, etc., if these are supported on carbon nanotubes rather than activated carbon, the activity increases 3 times. The support, the price is 20% more, but you get 3 times the property. So he will try to. So we have from every batch about 30% students, they start their factory. Next slide. There are many examples in industry. We are unable to export our chemicals or anything because our cost of production is high. So we have developed 3-point program: insight, innovation, and implementation, intensification and implementation. For example, the new example is the raw materials for drugs and pharmaceuticals. We buy worth 4,000 crores, about 16 of them. The real number is huge, but 16 intermediates we buy 400. We brought this to the attention of Department of Science and Technology of Maharashtra. They offered us 30 crores. I'll tell you what is my satisfaction within. These 16 molecules will be taken, each molecule, by one chemistry faculty and one chemical engineer faculty. We have a lot of experience, and I have confidence that we will make cheaper than China. But what is my benefit? Those 16 molecules, there will be 4 PhD students for every molecule, and 64 students will be graduated from my institution who will be capable to solve the nation's problem. That is important. Next slide. The problem of global warming is known to us. I want to give a very important message right now. We know that carbon dioxide, methane, and fluorine compounds, these are the greenhouse gases. And carbon dioxide has increased. So there is a professor from Japan, Manabe. He did paper calculations. And he proposed that if carbon dioxide in air increases 2 times, the earth will become warmer by 2.8 degrees. If carbon dioxide becomes half, it will cool down by 2.8 degrees. That is what his calculation showed. He got Nobel Prize. Renu madam, she has already enthused you. What I am trying to say, we feel in India, let us go abroad. There are good facilities, good library, good internet, good students. And we don't have. Nothing like that. And anyway, these are not important at all. What is most important is to ability to concentrate mind. That is important. If you are capable of concentrating mind on a focus problem, as she mentioned, then you can solve the problem. Then these are useful. Library is useful, internet is useful, but it is not mandatory. So kindly, my dear students, kindly develop this ability of concentrating mind, and you shall be in next 5 years from IACS, there will be another Nobel laureate. Only thing is, you please keep it in mind, concentration in mind, and don't complain in life. If there is little bit of salt more, you quarrel with mother, quarrel with. There is always big rains or small rains, there is no adequate rains, and you keep on complaining. My observation is, those who complain little bit, they get as if they have a khasi. Those who complain again and again, they have a cancer. So analyze yourself. You take one diary and every 20 minutes write down what is that you have done. Either you have been repenting about the past, or the anxiety of the future is not enabling you to concentrate the mind. So do meditation. We are endowed with this particular technique. Do it 3 times a day. Even if you are not successful for a minute, do it. Next time you will be able to do it 90 seconds, then 120 seconds, keep on doing. So don't complain in life. Complaining people never succeed. Right? And everybody in this audience, let the height be 6 feet or 4 feet 6 inches. Let the color be white or black. Hair be black or white. They may be long or short. All of you individually shall be successful. Don't complain. Don't complain. And develop an ability to concentrate. First of all, the visible effect will be you will be smiling all the time. And what do we do? If you get more money, then take shares, take another home. We increase the points of worry in life and don't focus. How can we focus if there is 2-acre plots in Noida? Problems. Next slide. This will be my almost what I have done here, the per capita income and carbon dioxide, they are parallel. They are one to another. Right now, our entire economy is 3.5 trillions, the nation's economy. And our Prime Minister and all of us, we feel that we should be 35 trillion. So right now, our energy production is 10,000 terawatt hours. For 35 trillion we need to make 40,000 trillion hours of energy. Because of CO2 problem, we are going to shut down coal-based power plants. Where the life is finished, there is going to be no extension. If you implement the entire area of the nation by solar, the entire wind available, put everywhere, and wherever waterfalls are there, small, large, big, biggest, but everywhere, and imagine that India has implemented all, then also we will make 10,000. We want 40,000. So none of these are individually capable of, so we need to develop technology, and only available technology is nuclear. What are the problems? Safety is the problem. Another problem is the initial cost. The third problem is any power plant to be built, that itself takes 8 years. So if there is 12% interest, while setting up the plant, at that stage itself, the total money is spent. And then later on, you have very, very expensive energy. Therefore, small modular reactors and micro modular reactors, this we have been developing, of course, with the help of BRC and within BRC. Money is required. Earlier I told you, earlier project we started with 60 lakhs. Then we got 10 crores. We got 33 crores. For this project, the small and micro nuclear reactors, we have already received 150 crores for developing this. And we need another 350 crores so that all the designs, individual designs, they can be. Godrej people have met us, L&T people have met us. We are confident that we will make 350, we will be able to get 350 plus 150 is already committed. So with 500 crores. Again, what is benefit? 100 PhD students will work on this project, 100, on different aspects of nuclear physics, nuclear chemistry, nuclear engineering, the thermal hydraulics, and 100 students will get educated, and such a educated manpower will be available to the nation. That is my driving force. I'm a teacher. Next slide. So here is the addition, 3,826 terawatt hours you will get after implementing everything that we have the nation has. Next slide. So this is the reactor. Maybe I'll try it. Here is the fuel. Water becomes hot under pressure, and then it reverses the direction. In those tubes, steam is made, and steam goes for the making of. So whatever 3 atomic power plants accidents have happened, in all the cases the pumps have failed. Whenever nuclear energy emits energy, that heat is taken by water and evaporates. Steam is separated from water and steam goes to turbine. There are various designs, this is one design. But imagine the pump which is pumping water to the nuclear fuel, that pump is stopped. then cooling stops. The local temperature keeps on increasing. At that temperature, water reacts with any metal to make hydrogen. Air is already there. So air and hydrogen explosion is there. So this way explosion happened in all the three cases. What was the point? Pump. So pump is deleted. No pump. Factory fabricated. So 8 years are not required. Micro means 5 megawatt hours. 5 megawatt. 5 megawatt, that will cost 14 crores. This is another point. If our nation buys micro modular reactor, it will be 40 to 80 crores of rupees per megawatt, 40 to 80 crores of rupees right now. Our technology, we are promising in 1/4, at least 3 times cheaper than the. Do research at the frontier, implement all the findings for the upliftment of, for the well-being of the society, and generate the new generation of boys and girls who are capable of taking these challenges. I'll stop here. There are many more things, but thank you so much.
Thank you, sir. May I now request our Honorable Chairperson, Governing Council, to sign the record of degrees. Thank you, Madam. We request our Honorable Chief Guest, Professor J.B. Joshi, to present the PhD degrees to the recipients of 2025. The names are being called in random order. Shourabh Gop, Supervisor Dr. Shotanarayan Mukhopadhyay, thesis title, Cosmology of an Internally Thermalized Dark Matter. Himanshu Sharma, Supervisor Professor Rajiv Goswami, thesis title, Total Synthesis of Thailandamide Lactone and Journey Towards the Total Synthesis of Thailandamide A, Nemamide A and Pneumocin B. Himanshu is not here today. Shukhendu Maiti, Supervisor Dr. Praveen Kumar, thesis title, Hybrid 2D Materials Based Self-Powered and Broadband Photodetectors. Shukhendu is not here today. Krishnendu Roy, Supervisor Dr. Praveen Kumar, thesis title Hybrid Two-Dimensional Materials for Electrochemical Hydrogen Evolution under External Stimulus. Krishnendu is not here today. Obhijit Patro, Supervisor Professor Narayan Pradhan, thesis title Facet Modulation for Designing Polyhedral Lead Halide Perovskite Nanocrystals and Their Epitaxial Heterostructures. Shouro Shankar Addi, Supervisor Professor Rajiv Kumar Goswami, thesis title Total Synthesis of Bacillotretrin C and Bipolamide A acetate and Studies Towards Amphetamines A and G Evaluation of Anti-Cancer Activities of Bacillotretrin C Analogues Generated via Systematic Structure-Activity Relationship Study. Ujjwal Majhi, Supervisor Professor Joyram Goin, thesis title Enantioselective Construction of CN and CC Bonds Using Non-Covalent NHC Catalysis. Shubhashish Mondol, Supervisor Professor Proshenjit Sen, thesis title Design and Synthesis of N-containing heterocyclic derivatives, investigating their biological applications. Shubhashish is not here today. Somshubhra Ghosh, Supervisor Professor Krishnendu Sengupta, thesis title Hilbert Space Fragmentation en route to ETH Violation and Reality. Somshubhra is not here today. Shubhankar Shutrodhar, Supervisor Professor Tapan Kanti Pain, effect of two or more metal centers on catalytic water oxidation and dioxygen reduction of non-Hem iron and copper complexes. Shubhankar is not here today. Indrajit Shah, Supervisor Professor Arnab Sen, correlated quantum systems with disorder and local constraints. Indrajit is not here today. Jayanto Dolai, Supervisor Professor Nikhil Ranjan Jana, thesis title Designing of Ultrasound Responsive Nanomaterials for Advanced Biomedical Applications. Atish Nag, Supervisor Professor Shurid Ghosh, thesis title Hydrogen Bonding Regulated Self-Assembly of Macromolecules and Functional Materials. Atish is not here today. Shukonna Bera, Supervisor Professor Shurid Ghosh, Amphiphilic Polydisulfide and Drug Delivery. Shukonna is not here today. Moinul Haq Sahana, Supervisor Professor Rajiv Kumar Goswami, Total Synthesis of Bioactive Natural Products, Stracereolide A and Sorangolide A with a journey towards the total synthesis of Zampanolide B. Moinul is not here today. Shayon Atto, Supervisor Professor Amit Mojumdar, thesis title Transition Metal Complexes of Polychalcogenides and Nitrite, Oxidation of Polychalcogenides and Reduction of Nitrite. Anunna Topadar, Shayon is not here today. Anunna Topadar, Supervisor Professor Shourabh Rai, thesis title Some Studies on Non-Thermal Production of Dark Matter. Anunna is not here today. Shomik Mukherjee, Supervisor Professor Shourabh Giri, thesis title Geometric Magnetic Frustration and Magnoelectric Coupling Without Long-Range Magnetic Ordering. Shomik is not here today. Deepanjan Rai, Supervisor Professor Deepak Kumar Sinha, thesis title Mechanics of the Cytoplasm, the Role of Cytoskeletal Filaments and Cytolinker Plectin. Deepanjan is not here today. Orithropal, thesis title Professor Kaushik Rai, Supervisor Professor Kaushik Rai, thesis title Conformal Integrals in Various Dimensions and Conformal Field Theories. Atanu Ghosh, Supervisor Professor Shurajit Sinha, thesis title Synthesis of Regular and Modified Morpholino Oligonucleotides and Automated DNA Synthesizer for Therapeutic Evaluation. Atanu is not here today. Bhargav Prasad Mondol, Supervisors Dr. Anuja Dotto and Professor Shurit Ghosh, thesis title Exploring Paper-based Thermoelectric Generators as Efficient Waste Heat Harvesters. Brij Mohan Pramanik, Supervisors Professor Debojyoti Das and Professor Ashim Bhaumik, thesis title Low-Range Synthesis of Carbon and Zinc Oxide Nanostructured Thin Films for Energy Applications. Shukallan Sham, Supervisors Professor Debojyoti Das and Professor Ashim Bhaumik, thesis title Growth and Characterization of Nanocrystalline Silicon, Germanium and Titanium Oxide Thin Films for Photosynthesis Sensitive Applications. Shukallan is not here today. Shaumo Jyoti Boshak, Supervisor Professor Jyotirmohi Dash, thesis title Synthetic Strategies for Construction of Biologically Active Heterocycles, quinazolinone alkaloids and their analogues. Mohammad Numan, Supervisor Professor Shubham Mojumdar. Thesis title, Exploring Quantum Magnetism and Multiferocity Through Cultural and Structural and Spectroscopic Studies of 3D Transition Metal Oxides. Rajesh Khamrui. Supervisor Professor Shurit Sinha. Thesis title, Supramolecular Biomaterials by H-bonding regulated aqueous self-assembly of naphthalene diamide derived amphiphils. Shubhendu Bishwas. Supervisor Dr. Anindita Das. Thesis title, Design and Synthesis of Degradable Functional Polyesters and Their Implications in the Biological Domain. Purnodash Ghosh. Supervisor Professor Arindam Banerjee. Thesis title, Carbon Dots Decorated Metal, Nanocomposites and Peptide Appended Various Rylene Dyes for Antibacterial Activities, Environmental Remediation and Optoelectronic Studies. Pulokesh Pramanik. Supervisors Professor Shantanu Bhattacharya and Professor Siddhartha Shankar Jana. Thesis title, New Small Molecular Entities as Therapeutic Agents via Selective Targeting and Stabilization of Secondary Structure of Nucleic Acids. Onushri De. Supervisor Professor Bimolendu Dev. Thesis title, Some Model Studies on Quantum Correlations in Strong Coupling Activity QED Regime. Ankon Kumar Sarkar. Supervisor Professor Nikhil Ranjan Jana. Thesis title, Design Nanodrugs for Subcellular Targeting and Prevention of Neurodegenerative Disease. Ankon is not here today. Arpon Chaudhuri. Supervisor Professor Deboshri Ghosh. Thesis title, Structural and Photoactivity of Melanin, a Combined Computational Chemistry, Machine Learning and Quantum Computing Study. Payal Shahu. Supervisor Professor Debojyoti Das and Professor Ashim Bhaumik. Thesis title, Design and Development of ZNO nanorod-based heterostructures, Application in Catalysis and Photovoltaics. Sharita Kole. Supervisor Professor Amitava Patro. Thesis title, Synthesis of Metal Nanoclusters, Self-Assembly and Excited State Dynamics. Rumela Odhikari. Supervisor Dr. Abhishek Das. Thesis title, Structural and Mechanism of Self-Assembly of Ultra-Short Peptides Insights from Atomistic Computer Simulations. Bhaskar Deb Mondol. Supervisor Professor Joyram Guin. Enantioselective selective construction of 3,3 disubstituted benzofuran 2,3H1s via non-covalent N-heterocyclic carbene catalysis. Bhaskar is not here today. Madhubroto Ghara. Supervisors Dr. Shinto Ghosh and Professor Raju Mondol. Thesis title, Exploring Intermolecular Interactions for Tuning Molecular Organization and Functions in Pi Conjugated Materials. Shubhajit Pal. Thesis title, Supervisor Professor Proshenjit Shen. Thesis title, Studying the Role of Blood Coagulation Factors in Chemotherapeutic Resistance and Cancer Immune Evasion. Shubhajit is not here today. Shumitabo Kundu. Supervisor Dr. Abhishek Das. Thesis title, Orientational Disorder in Crystalline Assemblies of Hard Particles. Shumitabo is not here today. Anupam Ghosh. Supervisor Professor Ayan Datta. Thesis title, Molecular Dynamics Simulations for Bimolecule Nanomaterial Interactions. Anupam is not here today. Pradipta Kumar Ghosh. Supervisor Professor Saurabh Giri. Thesis title, Magnetotransport and Magneto-Seebeck Studies of Topological Materials. Pradipta is not here today. Sujan Maiti. Supervisor Dr. Shubhadeep Datta. Thesis title, Magnetic Proximity Effect in Two-Dimensional Van der Waals Heterostructures. Saurabh Mondol. Supervisor Professor Rupa Mukhopadhyay. Thesis title, Structural Alterations in DNA Molecules Exposed to Exogenous Agents, an Investigation at the Single Molecule Level. Saurabh is not here today. Manik Jana. Supervisor Professor Horopriya Roth, thesis titled Controlled Synthesis of Core Modified N-Confused NC-Fused Porphyrinogen, Porphidomethanes, Porphidotrimethanes, and porphyrinoids with adaptive features. Didipriya Mollik. Supervisor Professor Siddhartha Shankar Jana, thesis titled Non-Muscle Myosin 2 Paralogs in Mechanotransduction Pathway and their Splicing at Loop 2 region. Swadesh Pal. Supervisors Dr. Anuja Datto and Professor Shurit Ghosh, thesis title Understanding Mechanical Energy Harvesting Potential in Piezoelectric Lead-Free Ceramics, Nanocomposites and Self-Assembled Soft Molecular Systems for Micropower Applications. Abu Raihan Sharkar. Supervisor Professor Nikhil Ranjan Jana, thesis title Development of Reactive Oxygen Species Generating Nanomaterials for Cell Therapy. Raunak Nath. Supervisor Professor Ankon Pal, thesis title Elucidating the Role of Protein Environment in the Catalytic Activity of Salicylate 1,2-dioxygenase Insights from Hybrid Quantum Mechanical Molecular Mechanical Studies. Joyanto De. Supervisor Professor Joyram Guin, thesis title Oxim Ether Group Transfer via Light-Induced Catalysis. Joyanto is not here today. Nobin Parui. Supervisor Professor Jyotirmoy Dash, thesis title Synthesis of Indole and Intanone Fused Ring Systems from Diketone Building Blocks via RCM. Arnab Dash, Supervisor Professor Surajit Sinha, thesis title Synthesis and Biological Assessment of Nucleobase Modified Phosphorodynamite for Morpholino Oligonucleotides. Kamal Hussain, Supervisor Professor Amit Mujumdar, thesis title Activation of chalcogens and Reduction of Nitride by Binuclear Transition Metal Complexes. Shumon Patro, Supervisor Professor Abhishek De, thesis title Mechanistic Investigation of CO2 Reduction by Iron Porphyrin Role of Second Sphere. Shumon is not here today. Priyanka Dinda, Supervisor Professor Torun Kumar Mondol, thesis title Polar Amino Acid Derived Polymers, Stimuli Responsiveness and Applications. Bikash Dash, Supervisor Dr. Shubhadeep Dotto, thesis title Electronic Transport Properties of Quasi One-Dimensional van der Waals Materials. Bikash is not here today. Shormishta De. Supervisor Professor Ankon Pal, thesis title DFT Studies on Fe oxyhydroxide nanoclusters, Growth Mechanism, Arsenic Binding and Catalysis. Shudeep Bhattacharjee, Supervisor Professor Oshim Bhaumik. Thesis title CO2 as C1 feedstock for the synthesis of valuable chemicals using porous nanomaterials as heterogeneous catalyst. Nasiruddin Mondol, Supervisor Dr. Debojyoti Mukherjee, thesis title Investigating Magneto-Oxy Kerr Effect and Topological Hall Effect in Epitaxial Ferromagnetic Thin Film Heterostructures. Sheikh Jisan, Supervisor Professor Dilip Ghosh, thesis title Study of Dark Matter Signature through Cosmological Observations. Oyon Dotto, Supervisor Professor Shudeep Malik, thesis title Design and Synthesis of Tetraphenyl-buta 1,3-diene-based monomers and polymers leveraging AIE characteristic to improve functional properties. Bikramaditya Mondol, Supervisor Dr. Shumanta Chakraborty, thesis title Quantum Features of the Universe, Aspects of Quantizing, Bouncing and Inflationary Cosmological Models. Arnab Ghosh, Supervisor Professor Prosenjit Sen, thesis title Deciphering the Significance of GPCR Mediated Signaling and Non-Coding RNAs in Cancer Immune Evasion. Arnab Bera, Supervisor Dr. Mintu Mondol, thesis title, Role of Symmetry in Quantum Phases and Phase Transitions in Transition Metal-Based VDW Materials. Madhusudhan Ghosh, Supervisor Dr. Partha Bosu Choudhury. Thesis title, From Textual Data to Structured Knowledge, a Computational Study on Neural Information Extraction. Saurabh Datta, Supervisor Professor Joyram Guin. Thesis title, N-heterocyclic carbene catalyzed asymmetric disymmetrization and kinetic resolution of alcohols via transfer acylation. Saurabh is not here today. Shubal Mondol, Supervisor Professor Pradyut Ghosh. Thesis title, Development of stereo and regioselective C/C/CO bond formation reactions using palladium catalyzed dinitrative and photocarboxylative pathways. Shoirik Dan, thesis title, Supervisor Professor Amlanjyoti Pal, thesis title, Electronic and Spin Transport in Compound Semiconductors, Advancement Towards Band Engineering and Chiro-Optical Activities. Oritri Pal, Supervisor Professor Shurit Ghosh, thesis title, Supramolecular Polymers of Polarizable Pi Systems and Functional Materials. Tanushri Banerjee, Supervisor Professor Shurit Ghosh, thesis title, New Organic Photosensitizers and their Stimuli-Responsive Polymeric Conjugates for Activable Photodynamic Therapy. Arpan Bera, Supervisor Professor Amlanjyoti Pal and Professor Saurabh Giri, thesis title, Effect of External Perturbations on the Electronic States of some Halide Perovskites and Transition Metal Dichalcogenides. Priyanka Roy, Supervisor Professor Deepak Kumar Sinha, thesis title, Studying the Impact of Membrane Tension, Extracellular Microenvironment and Cytoskeleton Diassembly on TNF-R1 Signaling. Saurabh Pramanik, Supervisor Professor Pradyut Ghosh, thesis title, Selective Recognition and Extraction of Iodine Perrhenate anion from water via chalcogen bonding interaction. Deeptam Nasipuri, Supervisor Professor Narayan Pradhan, thesis title, Colloidal Engineering of Perovskite Metal Halide Nanocrystals, Doping, Dimensional Tuning and Self-Assembly. Sheikh Kalimuddin, Supervisor Dr. Mintu Mondol, thesis title, Charge Density Wave and Critical Phenomena in Quasi-1D Compounds. Saurabh Mondol, Supervisor Professor Durga Boshak, thesis title, A Defect in Substrate-Induced Modulation, Photoluminescence and Photoconductivity of Undoped and Doped ZNO Thin Films and Monolayer of Few-Layer MOS2. Shantanu Pal, Supervisor Professor Durga Boshak, thesis title, Defect-Induced Modulation in Electrical and Magnetoelectric Transport Mechanisms in Transparent Conducting Oxide Films. Mohua Kaur, Supervisor Professor Torun Kumar Mondol, thesis title, Water-Soluble Amphiphilic Fluorophore-Based Polymers Synthesis, Stimuli Responsiveness and Biological Applications. Thank you, sir. May I now request Dr. Renu Swarup, Honorable Chairperson, Governing Council, to hand over the degrees to the MS degree recipients of 2025. MS degree from the School of Applied and Interdisciplinary Sciences, degree in Chemical Science, Polymer Science and Soft Matter, Devesh Shukla. Devesh is not here today. Pooja Banerjee. Shoumi Chando, Torun Kumar, Rima Dash. From the School of Applied and Interdisciplinary Science, MS in Physical Sciences Soft Matter, Kritika Bishas. G.R. Abhishek Rao. From the School of Applied and Interdisciplinary Sciences, MS in Biological Sciences with Molecular Biosystems and Biomedicine, Obhigyan Bosch. Obhigyan is not here today. Syed Sarwar Zaman, he is also not here today. Shulagna Chando. Arithra Bhaumik. Shagnik Mojumdar. Kushal Bhattacharya. Now from the School of Chemical Sciences, major in chemistry, Kaustubh Bagh. Shubhadeep Bhoj. Monoranjan Manna. Shongita Boyal. Aryavir Singh. Aryavir is not here today. Aditi Goswami. Shopnojit Bhor. Dharmendra Jaiswal. Kishalay Nandi. Kishalay is not here today. Shatakshi De. Gopeshwar Das. Vibhuti Bhushan Debnath. Vibhuti Bhushan is not here today. Orko Das. Anis Khan. Shubhrata Mahato. Mohammad Tuhin Sheikh. Sujoy Sheet. Mintu Patro. Lipika Boral. Now from the School of Mathematical and Computational Sciences, Mathematics and Computing, Specialization in Computer Science. Ananya Bhaumik. Ananya is not here today. Aranya Bhaumik. Aranya is not here today. Shutirtha Bhattacharya. Shaumadeep Kaur. Lavisha Sharma. From the School of Mathematical and Computational Sciences, Mathematics and Computing, Specialization in Mathematics, Thaneshwar Prasad Chaudhary. Rakesh Mondol. Shubham Goswami. Shubham is not here today. Shoumojit Raha. Now from the School of Material Sciences, with major in Chemical Sciences, Materials, Shamantak Rai Sarkar. Ilora Maiti. Shayan Majhi. Nochiketa Mahato. Nochiketa is not here. Hridoy Das. Shubhadeep Mondol. Orghodeep Panda. Chandan Panda. From the School of Material Sciences, major in Physical Sciences Materials, Aditya Patro. Deepayan Sarkar. Shomitabo Roy. From the School of Physical Sciences, major in Physics, Riju Ghoshal. Orijit Mondol. Rikshundor Gorai. Shubhodorshi Shahu. Shubhodorshi is not here today. Shonhita Guho. Samarjit Banerjee. Rohit Das. Bubai Laek. Shayon Maji. Biswas Anubhav Mehdi. Joydeep Borua. Thank you, Madam. May I now request Professor Kalobaran Maiti, Director IACS, to hand over the degrees to the BSMS degree recipients of 2025. Integrated Bachelor's Masters in Science with major in Biology, Orkojyoti Banerjee. Shehosri Mohanta, Shehosri is not here today. Brishti Pal. Shoumili Bishwas. Integrated Bachelor's Masters in Science with major in Chemistry, Sritama Bhattacharya. Pritam Boiddo. Shuchishmita Kormokar. Akashdeep Paik. Akashdeep is not here today. Aditya Bhattacharya. Aditya is not here today. Anirban Pal. Integrated Bachelor's Masters in Science in Mathematics and Computing, Specialization in Mathematics, Moitreya Bhattacharjee. Anurag Chatterjee. Integrated Bachelor's Masters in Science in Mathematics and Computing, Specialization in Computer Science, Sheikh Asif Iqbal. Bitan Sarkar. Girish. Medha Sen. Integrated Bachelor's Masters in Science with major in Physics, Shubham Chakraborty. Nilanjan Shashmal. Shihabul Haq. Shukonna Paja. Shayantan Nandi. Kannad Bhomik. Arnav Chauhan. Arnav is not here today. Shruti Kundu. Shaurin De. মানদাস বিশ্বাস, সুরজিৎ ঘোষ, প্রত্যয় চৌধুরী। Thank you, sir. May I now request our Honorable Chief Guest, Professor J.B. Joshi, to hand over the medals to the top performing students. Kishalay Nondi, from the School of Chemical Sciences, highest CGPA among MS recipients of all schools, gold medal. Kishalay is not here today. Highest CGPA among MS degree recipients from the School of Applied and Interdisciplinary Sciences, silver medal, Shulogna Chando. Silver medal for the highest CGPA among MS degree recipients from the School of Material Sciences, Shomitabu Roy. Silver medal for the highest CGPA among MS degree recipients from the School of Mathematical and Computational Sciences, Shomodip Kaur. Silver medal for the highest CGPA among MS degree recipients from the School of Physical Sciences, Shomhita Guho. Gold medal for the highest CGPA among all BSMS degree recipients, major in physics, Shihabul Haq. Silver medal for the second highest CGPA among all BSMS degree recipients, major in computer science, Medha Sen. Third highest CGPA among all BSMS degree recipients, silver medal, major in chemistry, Sritama Bhattacharya. Thank you, ma'am. Thank you, sir. May I now request our registrar, Ms. Sharbani Shah, to give the vote of thanks.
Respected Chief Guest, Honorable Chairperson, Governing Council, Director, members of the Governing Council and Academic Council, esteemed faculty, honored guests, dear students, parents, and members of the IACS family. It is my honor and privilege to propose a vote of thanks on this landmark occasion, the 5th annual convocation of the Indian Association for the Cultivation of Science that confluences with the 150 years glorious existence of IACS. At the outset, I extend our deepest gratitude to to our chief guest for gracing this convocation with his august presence and for delivering an inspiring address. Your words will undoubtedly leave a lasting impression on our young graduates as they prepare to chart their paths forward. Our sincere most thanks to Dr. Renu Swarup, Chairperson, Governing Council of IACS, who has been instrumental in guiding us in holding this convocation. Madam, your thoughts have enlightened our minds and have encouraged us to improve our organizing the event. Your quest for excellence and perfection was an inspiration for us to check every small component of this program. I sincerely thank all the members of the Governing Council and the Academic Council for their unstinting support and advice extended from time to time in defining the administrative and academic journey of the IACS deemed to be university. I would like to express sincere most thanks to our director for his unwavering leadership and vision that continues to propel IACS toward academic and scientific excellence. A heartfelt appreciation goes out to all the faculty members and research supervisors. Your dedication, mentorship, and intellectual guidance have shaped the scholars we celebrate today. To the parents and families of our graduating students, thank you for the encouragement and support you have provided throughout this demanding yet rewarding journey. To our students, this day is a tribute to your hard work, resilience, and curiosity. We are proud of your achievements and confident that you will represent IACS with distinction wherever your future takes you. I would also like to acknowledge the tireless efforts of the administrative team, support staff, and the organizing committee under the most able leadership of Professor Shurit Ghosh, Dean Graduate Studies and Student Affairs and Chairman of the Convocation Committee, whose meticulous planning and coordination have made today's event a success. Finally, to all our guests and well-wishers, thank you for being part of this celebration. Your presence adds warmth and significance to the convocation. Let this event remind us of the collective strength of our academic community and the responsibility we share in shaping the future of science and society. Thank you once again.
May I now request our Dean Graduate Studies and Student Affairs and Chairperson, Convocation Committee to declare the convocation closed.
May I have the permission to declare the convocation closed? May I have the permission to declare the convocation closed? Okay, I declare this convocation ceremony closed.
Request everyone to rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय